Hey guys, we know you're struggling with calculus, so we're here today to help you with some definite integrals. Okay, so judging what you already know from indefinite integrals, we're going to take it a step further. With definite integrals, we're finding the area under this curve. And this A and this B right here are called our bounds. And so this is a certain domain we are given, so we are going to find the area from a certain domain. So in this case, we're going to start easy, and we're going to go look at the domain of f of x equals x from 0 to 5. So we're looking at here 0 to 5. Okay, so we're going to first integrate this thing, and we know that's 1/2 x squared. But now we have to take into the count 0 and 5. So what we're going to do is put this 5 right here and the 0 here. Okay, so now with definite integrals, the thing we have to do is do this domain minus this domain. And both of these, when I say domain, you plug it into the x value. And so you're going to do this x value minus that. So. And there it is.
Alright guys, so for this example we have a basic polynomial, and the first thing you're going to want to do is integrate as usual. So we'll start off with x squared, so that's going to be 1/3 x cubed, and then plus x squared since the 2 cancels out, and then plus 3x. And then you're going to put the bounds right here to remember to subtract 3 from 0 once you plug it in. $27.
Okay, so our next example is a semicircle. And the way to recognize that is you're going to have perfect bounds of -4 to 4 or -3 to +3. And it's a perfect square of this in this square root. And then it's going to be minus x squared. And that's going to give us the shape of a semicircle. And so once we do that, we're going to just find the radius of this number right here, which is 4, because 1, 2, 3, 4. And then just simply plug that into our area function of a semicircle. So with this one, you don't even really need to do integration. And there we go, that's our answer. And so the way we got that was just simply from our radius of our semicircle. And so then plug it into the equation and then you're good.
Okay, this one may seem tricky, but none of this stuff right here matters because the bounds are the same, so that means there is no area under the curve to evaluate. So that's going to be an automatic 0.
Okay, our next example involves trig. And so this goes back to knowing your trig identities. I know they're kind of hard at first, but once you get them down, it's really going to help you. So first we're going to integrate this, and then just evaluate it at our points. And there's your answer. And so it's just the same as a regular integral, but now you're just doing trig with it. So.
Okay, so this problem is going to involve a method called u substitution, and what it's going to do is it's going to take all the x's out of the problem and put it in terms of u in hopes of making integrating it a little bit easier. And typically the u that you're going to use is going to be part of the function with the highest power. Okay, so for this problem, u is going to equal x squared plus 2. And then after you have your u, you're going to take the derivative of this, which will be 2x, and that's going to be your du, and that's going to get rid of the dx right here. So du equals 2x dx actually works out perfectly in this problem because we have a 2x right here and dx, so those are going to cancel out, and we're going to get the integral of u squared du. So now that x is in terms of u, we also have to make sure the bounds are also in terms of u to make the problem correct. So we do this by plugging in u of 0 and u of 1.
And this is going to equal 0 squared plus 2 equals 2. And this will equal 1 plus 2 equals 3.
So it's going to become 2 to 3. So now at this step, you're just going to integrate as normal since everything's in terms of u. So that's going to be u to the 3rd over 3 with bounds from 3 to 2. So now it's time to plug in the bounds from 3 to 2.
So subtract 3 right now. Subtract it from 2. That's going to give us 9 minus 4/3, which equals
19 over 3.
Okay, so the next concept we're going to look at is something called average value. And so this can be shown by this equation right here, 1 over b minus a, which is just our bounds on our integral function. And so if we're given a word problem like this, we can just write it out as this is our b and that's our a. And so now we need to write this as an integral. But first, we're going to put this fraction in front of the integral. So 2 minus 0, and then integral top bottom function of this f of x, which is just going to come down right here. And now we just integrate this as normal and then plug in our bounds.